Today we are going to learn about mastering batch predictions in Python. We'll explore setting up and executing batch predictions for large datasets using Python libraries, enhancing your machine learning workflow.
Welcome to our session on mastering batch predictions using Python. Batch predictions allow you to process large datasets efficiently by predicting outcomes for multiple data points simultaneously, rather than one at a time. This approach is crucial in machine learning for saving time and computational resources, especially when dealing with extensive datasets. Compared to real-time predictions, batch predictions offer greater efficiency and are less resource-intensive. Throughout this video, we'll explore the tools and techniques you need to set up and execute batch predictions effectively using popular Python libraries.
To begin, it's essential to have a well-configured Python environment. First, ensure Python is installed on your system. You can download it from the official website. Once installed, use tools like Anaconda for easy package management and environment setup. Anaconda helps you manage dependencies and versions efficiently. Alternatively, you can use pip alongside virtualenv to create isolated environments, preventing conflicts between different projects. Setting up a virtual environment involves creating a directory for your project and activating it, ensuring all dependencies are installed within this isolated space. This practice is critical for maintaining a clean and organized development environment.
Data preprocessing is a vital step in preparing your dataset for batch predictions. Pandas, a powerful data manipulation library in Python, is your go-to tool for this task. Start by loading your dataset into a Pandas data frame. This structure allows for efficient data manipulation and analysis. Handle missing data by filling or dropping them using Pandas methods. Conduct feature engineering to enhance your dataset, creating new features that can improve model predictions. Finally, ensure your data is clean and optimized, free from inconsistencies and ready for the prediction phase. Preprocessing sets the foundation for accurate and efficient batch predictions. Scikit-learn is a robust library for machine learning in Python, providing tools for implementing batch predictions. Begin by training a model on your preprocessed dataset. This involves selecting an appropriate algorithm and fitting the model to your data. Once trained, you can use the predict function to perform batch predictions. Consider the size of your batches, as larger batches can be more efficient but may require more memory. Evaluate your predictions to ensure accuracy, using metrics like accuracy score or mean squared error. Scikit-learn simplifies the process of executing batch predictions, making it accessible and efficient.
When dealing with extremely large datasets, Dask is an invaluable tool. Unlike Pandas, Dask can handle data that doesn't fit into memory by breaking it into smaller, manageable chunks. Dask facilitates parallel processing, allowing operations to be executed concurrently, thus speeding up computation significantly. You can create Dask data frames similar to Pandas, enabling seamless integration. Moreover, Dask can be integrated with Scikit-learn for distributed machine learning, allowing you to train and predict on large datasets efficiently. Utilizing Dask ensures your batch predictions are scalable and capable of handling extensive data volumes. Optimizing your batch predictions involves leveraging Python's multiprocessing capabilities. This allows you to utilize multiple CPU cores, significantly enhancing performance. The multiprocessing module in Python provides an easy-to-use API for parallel processing. Start by creating processes that execute your prediction tasks concurrently. This setup can lead to substantial time savings, especially for large datasets. However, be mindful of common pitfalls, such as data sharing between processes and potential overhead. Properly managing these aspects ensures you harness the full power of multiprocessing, achieving efficient and fast batch predictions. Implementing a robust logging system is essential for tracking and monitoring batch prediction outputs. Logging provides a record of prediction activities, helping in debugging and performance analysis. Python's logging module offers a flexible framework for creating logs. Set up a logging system that captures key events and errors during batch predictions. This setup aids in monitoring outcomes and identifying potential issues. Regularly review logs to ensure predictions are performing as expected, making necessary adjustments to improve accuracy and efficiency. Logging is a critical component for maintaining a reliable batch prediction pipeline.
Deploying batch predictions involves several best practices to ensure smooth operation. Start by preparing your models, ensuring they are optimized for deployment. Automate batch processes using tools like cron jobs or scheduling services, which reduce manual effort and increase reliability. Consider scalability, ensuring your system can handle increased loads efficiently. Security is paramount. Protect your data and models against unauthorized access. Finally, implement continuous integration and deployment practices to keep your prediction pipeline updated and robust. These best practices ensure your batch predictions are efficient, secure, and scalable.
In conclusion, mastering batch predictions in Python empowers you to handle large datasets efficiently, optimizing your machine learning workflows. We've covered essential tools and techniques, including setting up your environment, using Pandas for preprocessing, implementing predictions with Scikit-learn, and handling large data with Dask. Remember to leverage multiprocessing for performance optimization and maintain a robust logging system. As you continue to practice and explore, you'll refine these skills, enhancing your ability to deploy efficient batch predictions. For further learning, explore the resources provided, and keep experimenting with these powerful tools.